Okay, continuing on in geometry, we are now going into three-dimensional objects. So this is going to be the introduction to three-dimensional geometry. Now, three-dimensional geometry becomes a little bit more interesting because it's very hard to draw three-dimensional objects on a two-dimensional piece of paper or on a board. But we'll do our best here to picture three-dimensional objects. So I just want to outline the relationships between dimensions. So at 0 dimensions, we have a point. Okay, and when a lot of the points line up and extend in one direction, so the point is going this way, it becomes one dimension. And this is a line now, or you could say a line segment or array, depending on which way the line is moving, or if it is moving. So this is a one-dimensional, I'm going to draw a line segment here. This is a one-dimensional object. Now at two-dimensional, or at 2 dimensions, we are extending this line. So we have a line, and we are extending this line down this way. So we're extending that line. Okay, so it's going this way, and we get a plane figure. Okay, so at 1 dimension, we can only move back and forth. So we can either move this way or this way. At 2 dimensions, we can now move this way, or we can also move this way and this way. Okay, so when you are thinking of a screen or a piece of paper, and let's say you are drawing on a piece of paper, and without lifting the pencil, you can move your pencil around the piece of paper like this. And this is basically the direction in which two-dimensional objects can go. It can either go forward, or backward, or down, or up, or it could be a combination of both. So it could go like up and then up towards the right, which is going to be like this. Or it could be like down and towards the right, which is going to be like that. Down and towards the left, like this. So you can move inside the plane, but in 2 dimensions, you can't move away from this plane. So now, if we go into 3 dimensions, 3 dimensions, we have the 2-dimensional plane, and now this 2-dimensional plane is moving upwards. So think of it, it's hard to do this on a 2-dimensional computer screen, but think as if this rectangle here is jumping up at you. It's popping out from the screen. I don't even know how to draw an arrow to signify that. So the best way to visualize 3-dimensional objects is to draw like this. Okay, so it's going to look like a box. Okay, so the 2-dimension was right here. Okay, that was the 2-dimension, and then it popped out from the screen like this. Popped out from the screen. So at 2 dimensions, we had length and width. In 3 dimensions, we have length and width, but now we have height. Okay, at 1 dimension, we only had length. We can only move forward and backwards. Okay, so every time we move up a dimension, a new component is added. Okay, so at 2 dimensions, width was added. In 3 dimensions, height is added. And the objects that you see in real life with your eyes are mostly all 3 dimensions. Okay, you don't really see two-dimensional objects in real life because no matter how thin they are, they actually have a height. Okay, so look around on your desk right now. You might see a book. That's three-dimensional. That's a three-dimensional shape. So a book is going to look like this. It has a length and a width, and it also has a height. Okay, the book is like sticking out. It's not like flat on the floor. It's sticking out from the floor or from the desk. Okay, so at 3 dimensions we have, it's called solids now. Solids. In 2 dimension it was called plane. Okay, so this is what 3 dimensions mean. So if you are picturing a 3-dimensional object, it's actually, you have to use your imagination to draw 3-dimensional objects on a piece of paper, because a paper, or what you can draw on a paper, is only 2-dimensional. You can't actually draw things that are sticking out from the paper. Okay, so I'll do my best to visually represent the 3-dimensional, or the basic 3-dimensional solid that we'll be learning. So the 3-dimensional solids. And I like to categorize these into groups. Okay, so first we have the prism group. And basically a prism group, you can think of a 2-dimensional object, or two 2-dimensional objects at both ends. So on this end we have, say, a rectangle on this end, and then on the other end we also have a rectangle. Actually, I should write like this. So think of these as a rectangle that's like standing on its side. So let me draw a desk here to help you visualize that. So this, actually, let's use a different color here. So the green part is the desk with the legs. The legs of the desks are like this. Okay, and the rectangles are like standing on end. So this is up against the desk. This is up against the desk. Okay, so a prism basically has two 2-dimensional shapes at both ends, and we're just connecting the sides. Oops, you're connecting each of the sides by a plane like this. So this is what prisms look like. So I'm just going to color this in. Okay, this is what prisms look like. It has a 2-dimensional shape at both ends. In this case, it's a rectangle. It has another rectangle on this end. And then there are planes that connect the sides. So it connects this side with this side with this side. Or another way of picturing this is given a rectangle like this. So imagine this rectangle just popping straight up at you. Okay, I can't draw that on a 2-dimensional board, but just think of this rectangle popping straight up at you, and then let's say it stopped after like 3 centimeters. Okay, so it's going to be, that's a prism. It's a 2-dimensional object that's being stretched. Okay, that's being stretched. So what goes into this prism family? So this, what we have here is a rectangular prism. Actually, let me write the names down here. So the rectangular prism looks like this, what we've drawn up here. Let me just redraw this a little bit more neatly, hopefully. The dotted parts are on the other side. Okay, rectangular prism. And then I think this is the most well-known prism shape. It's a cube. Okay, and obviously a cube is a square on all sides, or has squares on all sides. So cube is also a prism family because a square has been stretched out this way. Okay, we have a cube. We also have a triangular prism. And this is what happens if you stretch a triangle. So let's say you have a triangle. You've stretched out this triangle like this, and you get a triangular prism. Okay, and then what do you think happens if you stretch out a circle? Okay, it's going to be something like this. Okay, and that is called a cylinder. So these are all prism families. You stretch out two-dimensional objects so they have the same shapes on both ends. So in this case, we have rectangles on both sides. In this case, we have triangles on both sides. In this case, we have circles on both sides. In case of cubes, we have squares on both sides. Okay, and then next we have the pyramid family. So instead of extending the two-dimensional shape, we have the two-dimensional shape. So let's say a square on the floor. It's squares on the floor. And then above the square, we have a point. And imagine like each of the vertices of the square are being connected to that point. Okay, that is called a pyramid. So in this case, this is a square pyramid. Square pyramid. If you have a triangle on the floor and a point above the triangle, and we're connecting each of the vertices of the triangle to the point, then we have a triangular pyramid. Okay, and then if you have a circle on the floor and a point above the circle, and circles don't have vertices, so basically all the points around the circle are being connected to this point here. And this is called a cone. I'm sure you're very familiar with cones, as they're very common in ice creams. Okay, so these are the pyramid families. Okay, and then the last one is, I don't categorize this as a family, but it's worth noting. And this is a sphere. Okay, a sphere is basically a ball. I think you're more familiar with the concept of a ball. It's hard to draw that on a two-dimensional shape here. So it's just, the official definition would be you have a point, and it's the set of all points that are equidistant from that point. So if you have a center here in the middle, a circle is equidistant. It's equidistant in 2 dimensions. A sphere is equidistant in 3 dimensions. So imagine that this is popping out from the screen, and also it's like extending out under the screen here. So it's like a ball shape, or a globe shape. Okay, so that's called, the official name for this is a sphere. So that's what a sphere is.